Hello, and my presentation today is on excess hydrogen sulfide and poly-sulfide production and how it underlies a schizophrenia biomarker. So this research was done by a large group of scientists, with the lead researcher being Masuke Aide at the Laboratory of Molecular Psychiatry in the Riken Center for Brain Science in Wako, Saitama, Japan. Masuke is an accomplished neuroscientist with multiple important publications, as well as multiple patents for devices to aid in brain research. This research is quite new, with it being published this passing Monday on the 28th. So these scientists in Japan have discovered that a subtype of schizophrenia is related to abnormally high levels of hydrogen sulfide in the brain. They discovered this by working with model mice, post-mortem human brains, and people with schizophrenia. Their experiments showed that this abnormality was a likely result from a DNA-modifying reaction during development that lasts throughout life. Researchers believe that in addition to providing a new direction for research into drug therapies, higher than normal levels of hydrogen sulfide producing enzymes could act as a biomarker for this type of schizophrenia. They found this by working with an occurrence called pre-pulse inhibition, or PPI, in mice and then later humans. PPI is best explained as an abnormal startle response. Normally, we're not startled as much by burst of noise if a smaller burst, called a pre-pulse, comes in a little bit earlier. This is because the early pulse inhibits the startle response. In people with schizophrenia, PPI is lowered, meaning that their startle response is not dampened as much as it should be after the pre-pulse. And because of this, for the last 30 years, PPI has been a good behavioral marker for schizophrenia, and their researchers aim to look into the differences of mice's brains with high and low PPIs. Ultimately, they found that the enzyme MPST was expressed much more in the brains of the mice with low PPI than the brains of the mice with high PPIs. Knowing that this enzyme helps produce hydrogen sulfide, the team then measured hydrogen sulfide levels and found that they were higher in the low PPI mice. The figure to the right shows how high levels of hydrogen sulfide, also called sulfide stress, causes a dampening of energy metabolism. So after a series of tests to clarify that the enzyme was MPST, the researchers had enough information to move on to human observations. So they examined the hair follicles of 150 patients with schizophrenia and found that expression of MPST mRNA was much higher than people without schizophrenia. Even though the results were not perfect, indicating that sulfide stress does not account for all cases of schizophrenia, MPST levels in hair could be a good biomarker for schizophrenia before other symptoms appear. The development of schizophrenia is related to both a person's genetics and their environmental area. The heightened amount of MPST would be one of the genetic markers, while the environmental aspects could be tied to inflammatory and psychological stress. Because hydrogen sulfide can protect against inflammatory stress, the group hypothesized that inflammatory stress during early development might be the root cause. I also personally believe that this research could also further advance the notion that early marijuana usage can cause schizophrenia later in life. With this recent research, drug companies can focus on trying to develop new drugs that target hydrogen sulfide producing enzymes, which could work better than the current medications that target serotonin and dopamine symptoms in the brain that rarely work as well. Thank you, and here are my references.